Okay, this is 10.3, part 1. We're going to talk about compound interest. And in the real world, compound interest is probably the most applicable out of the things that we've learned besides percents. So usually CDs, which is called certificate of deposit or money market accounts, are ways to save money. And what happens is you put money in and you gain interest on that money. And then it has terms to it. So it could be you agree to a terms of a year, 6 months, 5 years, whatever. And then you can get your money back. So basically you're letting the bank borrow the money. And that's why you get the interest on it. So if you let the bank borrow the money for a longer time, usually the interest rate becomes higher. But there's a caveat to placing your money in a CD, and that is whatever agreement you make, if it's 1 year, you cannot take your money out before that 1 year is over without, being assessed tons and tons of fees. So that's the only issue with CDs, but generally you can make more money, and typically you can make more money than you would if you just left your money in the savings account because the interest rates are higher. So really quick, I am not a financial advisor. I am not licensed to practice that or registered. So I'm not giving you any financial advice here. I'm just telling you the basic facts of CD versus savings account. Okay, so let's go ahead and talk about compound interest. So we saw simple interest last section, and simple interest is I equals PRT. So let me just put simple interest, I equals PRT, where P was principal, R was a rate, T is time. So just like the simple interest formula, compound interest, the P stands for the principal, the R stands for the rate, and T stands for the time. So that's nothing new. So the formula looks like this. A equals P times the quantity, 1 plus R over N, and all of that raised to the NT. Okay, so A is the amount of money that is interest plus the principal. So this is going to be the whole shebang. The R is the rate. Remember, rate's given in percent, so we have to change that to a decimal. T is time, and it is in years. So once again, we have to be cognizant of that. P is a principal. And N is the number of times the amount is compounded. Okay, so this is new, and it's basically N. How many times is it compounded? It makes sense because remember we're looking for compound interest. Okay, so A equals P times the quantity 1 plus R over N raised to the NT. So you need a scientific calculator to be able to do these, and the reason why is because you've got this exponential value right here that we need to deal with. Okay, so a side note about N. So if N has to be equated in years, so if it's compounded semi-annually, it's kind of like those sales that you see, the semi-annual sales, that means that N equals 2, because semi-annually means twice a year. Compounded annually, if you have an annual sale, that happens once a year, so N equals 1. Compounded daily, we're not going to use 365. We're going to use that value of 360. So that's what the banking institutions usually use. So N equals 360. And compounded monthly, there's 12 months in a year, so N equals 12. So there's some just examples of what you may run into, and that's how you would write them up. So remember, N means how many times is compounded per year. Okay. So let's go ahead and look at objective 1 here. Objective 1 says for the next 2 examples, use the compound interest formula to compute the total amount accumulated and the interest earned. Round all answers to the nearest cents. The reason why we're doing nearest cent, which is the nearest hundreds, is because we're talking about money. So basically, if we have a value, I'm going to take it 3 decimal places after the decimal sign, and then we'll round to that hundredths place. A word of warning: do not truncate your values, or do not reduce your values down inside of the equation. When you deal with money, that can throw your answer off thousands of dollars. So it's very serious. Like, don't do it. I know you're going to get some huge numbers and you're going to be tempted to round them or truncate them. Don't do it until the very end of the problem. All right. Also, make sure you have a scientific calculator out before you start doing these, because you should walk through it just to get used to it. And I'm going to tell you the exact order in which you're going to plug it in your calculator. And if you do it my way, I promise you it'll be the easiest way that you can do without making a mistake, okay? So here we go. So the first example says there's $4,000 for 2 years at 6% compounded semi-annually. So we're supposed to find the compound interest. Do you see how it says compounded? That's how I know I have to use the compound interest formula, which is A equals P times 1 plus R over N raised to NT. Okay, because of that word, it doesn't say simple interest, it says compounded. So let's go ahead and figure out what all these are. The principal is $4,000. The rate is 6%, but remember we have to use a decimal, so 2 places to the left, 0.06. The time is 2 years, and N, compounded semi-annually, equals 2. All right, so now that we have those values, we're going to plug and chug them in. So amount equals 4,000 times 1 plus rate, 0.06, over time, which is 2, raised to the n, which is 2, times time, which is 2. Okay, what I'm going to do is I'm going to go ahead and simplify that exponent. So I'm going to write this down as A equals 4,000. 1 plus 0.06 over 2 raised to the 4th power. Now I'm ready to work with this. So according to the order of operations, or maybe you've heard, please excuse my dear Aunt Sally, that's a mnemonic device for deciding what to do first, we always have to start inside the parentheses. And because division is of higher order than addition, you have to do that first. So the first thing we're going to do is we're going to take 0.06 over 2, and we're going to find out what that value is, and then we're going to add 1 to it, okay? So this becomes A equals 4,000 times 1 plus, and when I divide 0.06 by 2, I get 0.03. And this is raised to the 4th power. So now I continue to work inside of parentheses, and I'm going to add 1 plus 0.03. And when I do that, I get 1.03. And I'm just writing down the rest of the problem. Now that we've simplified inside the parentheses, we have to move on to the exponents. So I'm going to take in my calculator and I'm going to take 1.03 and raise it to the 4th power. And when I do that, I get this. Whoops, I don't get that. Wrong tool. I get 4,000 times, and when I put 1.03 to the 4th power, I get 1.12550,881. And that's what I was talking about. Do not truncate the number. Do not round it until the end. Okay? All right. So I'm going to multiply those two together. So I take in my calculator now and multiply 4,000 times 1.12550,881. And when I do that, I get amount equals 4502.035. And once again, I took this out to the 3rd decimal, or 3rd place value after the decimal, because I'm going to round it. Or maybe not round it, just depends what the value is. So in this case, the value is a 5, so I know I have to round the digit in front of it up. So instead of 0.03, it's 0.04. We're talking about money. So we have $4,502.04. But I'm not done, because For these problems, it said to find both the amount and the interest. So to find the interest, that we have earned, it's very, I spelled it wrong. To find interest that we've earned, it's very easy. We take the amount minus the principal, and that'll give me the interest. So if I take $4,502.04 minus $4,000, the interest that I've earned on this is $502.04. So that's interest. So that's not bad. Okay. All right. So let's go ahead and look at the next example. $7,000 for 3 years at 5.5% compounded monthly. So we're going to write down what we have. P equals 7,000. Time is 3 years. The interest rate is 5.5%. Got to change that to a decimal, so 0.055. Compounded monthly. So N equals 12. And because it says compounded, I'm going to use the formula. A equals P times 1 plus R over N raised to the NT. Okay, so if you put that in there, amount equals 7,000 times 1 plus the rate, 0.055, over N, which is 12, raised to the NT, 12 times 3. So once again, I'm going to take care of this exponent so it looks a little better. 12 times 3 is 36. So amount equals 7,000, 1 plus 0.055 over 12, raised to the 36th power. Okay, now I told you to work inside the parentheses first. So in my calculator, take 0.055 divided by 12. And when I do that, and I get 0.0093, and I add 1 to that, so I basically just took care of both. You know, I add 1 to that value, 0.0093, I get 1.0093. Oops, sorry, wrong value. So if you're like, no, you don't, you're right. Let's look at the wrong problem, guys. I get a huge number. And let me just back up a second. So 0.055 divided by 12 is actually 0.00458333333. And if I add 1 to that, I get 1.00458 and lots of 3's. Okay. And then I'm going to raise that to the 36th power. So my next step is to take 1.0458333, raise it to the 36th power. And when I do that, I get amount equals 7,000 times 1.178948602462. Okay? Now I'm going to multiply that number that should be still in your calculator times 7,000. And when I do that, I get 8252.64. 0. Okay, so once again, I take it to the 3 place values after the decimal. Now I'm going to round. So the amount that I get by putting my money in for 3 years at 5.5% compounded monthly becomes $8,252.64. Yikes, what the heck. All right, and then the interest that I'm going to earn, remember I take amount minus principal. The amount was 8252.64 minus 7,000. And when I do that, I get $1,252.64. That's the interest that I earn over that time period. So it's really great because, you know, you put $7,000 in and you get $8,252.64 for just 3 years. It's pretty cool. All right. We're doing this one. Marcus, he receives an inheritance of $6,500. He decides to invest his money in a 5-year CD that pays 1.86% interest compounded semi-annually. How much money will Marcus receive when he redeems the CD at the end of 5 years? So the compounded semi-annually lets me know that, hey, I'm going to have to use the compound interest formula, which is A equals P times 1 plus R over N raised to NT. And yes, you have to memorize that. I know some of you are probably thinking that right now. So let's go ahead and write everything down. The principal is the amount of money he gets, so that's $6,500. The rate is 1.86. Remember, got to change that to decimals, so 0.0186. The time is 5 years, and compounded semi-annually, N equals 2. So let's go ahead and plug that in. So A equals P times 1 plus R over N raised to NT. Amount equals 6,500 times 1 plus rate 0.0186 over N, which is 2, raised to N, which is 2, times time, which is 5. So once again, let's go ahead and take care of that exponent. So if I multiply 2 times 5, I get 10. And now it's time to do the problem. So what I'm going to do is I'm going to divide on my calculator 0.0186 divided by 2. And when I get that answer, I'm going to add 1 to it. So when I do that, I get 1.0093 raised to the 10th power. So now that you have 1.0093 in your calculator, leave it there and take it and raise it to the 10th power. So when you do that, you get, or at least what I got was 1.0969901611417. So since that's the number sitting in the calculator, go ahead and just multiply 6,500 to it. And when you multiply the two together, you should get 7130.436. Remember, take 3 decimal places out because I need a round because it's money. So my answer is going to be 7,130.44. So that's how much money Marcus is going to receive at the end of the 5 years with those stipulations. Okay, so, he didn't do too bad. All right, so let's go see if there's one more. There is, and then part 2, we're going to have the present value formula. So let's read it. Marcy wins a prize in the sweepstakes and receives a check for $250,000. After spending $10 on the vacation of her dreams, she decides to invest the rest of the money in a money market account that pays 1.5% interest, compounded monthly. So once again, we see that compounded monthly. We're going to know that we have to use the compound interest formula, which is A equals P times 1 plus R over N raised to NT. Okay. How much money will be in the account after 10 years? What is the interest on this money market account? Was compounded daily. So we have a part A and part B. So I'm going to part A over here. We're going to first see compounded monthly. So for the first one, compounded monthly, N equals 12. Her interest rate is 1.5%. So remember, we have to use 0.015. The time is 10 years. And then the principal, remember, she was given a check for $250,000, but she spent $10,000 of it on a vacation. Don't blame her. So what we get is $240,000, and that is my principal. So that's what I'm going to plug in. So let's go ahead and use those quantities. So amount equals $240,000 times 1 plus the rate, which is 0.015, over N, which is 12, raised to N, which is 12 times time, which is 10. Okay, so once again, make this look better before we start working it. When I multiply 12 times 10, I get 120. Okay, So now we start the calculator business. So divide 0.015 divided by 12, add 1 to that. And when you do that, I get 1.00125, and I'm going to raise that to the 100th 20th power. Okay. Now, your next step is going to leave that number sit in your calculator, raise it to the 1/20th power. And when you do that, you get 1.161725416,548. So take that number in your calculator, multiply it by 240,000, and the amount that she's going to get at the end of the 10 years is $278,814.099. So we have to round up because this is a 9. That's much bigger than 5. So the amount that she's going to get is $278,814.10. Okay, so that was part A. Part B says, hey, what happens when, this is compounded daily? So if it's compounded daily, n equals 360, the rate stays the same, which is 0.015 after it's been changed. The time is 10 years. The principal is still 240,000. Okay, so we just use this again. So amount equals 240,000. 1 plus rate 0.015 over n, which remember now is 360. Raise the n, 360 times t, which is time, which is 10. So same process. You take this and you change that to 360 times 0, so 3,600, and you start the process again. This time around, we're going to multiply 0.015 divided by 360, and then we're going to add 1 to that. All right, so when I take 0.015 divided by 360, I'm going to find that that's going to give me, and I add 1 to that. Let me just tell you that. I get 1.00041666667. Okay, and I'm going to raise that to the 3,600th power. So hopefully you leave that number in your calculator, raise it to the power of 3,600. And when I do that, I get, a huge number again. So this becomes 1.161830612,103. It's almost, by the way, it's almost pi, 1.618, but there's an extra 1 in there, so it's not. Okay, we got to leave that in our calculator, and then we multiply it by 240,000. And when I do that, I get 278,839.346. Once again, round. So $278,839.35. So that's how much money Marcy is going to make if it's compounded daily. So the question is, do I make more money if it's compounded daily or if it's compounded monthly? And if we compare the two, we see that daily is going to give us more money. So the moral of the story is the more this amount is compounded, the more money you make. In this case, we got about $35 more. Okay, all right, that's the end of part 1. There is a part 2 which talks about present value.